Number 25. This is just asking you to think backwards, so don't get upset. These actually help us to, they really help us to learn this stuff. Okay, notice here that our carbonyl group, we've got a ketone. So, since we had a ketone, the alcohol that it came from would have had to have been a secondary alcohol. So this is going to be real easy. Also notice that this is not a benzene ring. Okay, this is just a cyclohexane. So it would have simply been this before the reaction, before the oxidation reaction. Okay, remember this is a secondary carbon because this is connected to two other carbons. A secondary alcohol, when it is oxidized, will give you a ketone. If we look at B, notice that our functional group here on B is an aldehyde. Carbonyl group, double bond to an oxygen with the hydrogen there. So we've got 1, 2, 3, 4 in this parent chain. 1, 2, 3, 4. Okay, notice methyl group coming off of this one. We got a double bond here. So an aldehyde, this is what forms when a primary carbon, that is carbon that is attached only to one other carbon. Okay, so our alcohol is just kind of hanging off the end here. In a primary carbon, that alcohol is hanging off the end. Okay, so now had this been an aldehyde, or had it been a carboxylic acid, either way it would have come from that. We take a look over here at C, and this is a carboxylic acid because we got a carbonyl group with, the C double bonded to an O and then an OH right here. And then I just want to draw your attention, this is a benzene ring because we got the 3 double bonds. We've got the sulfur here, so that's not anything that we have to worry about. We'll just kind of put that there for good measure, I think. But what they want to know is what this would have come from. And again, this is a primary carbon. It would have come from a primary alcohol. In this case, a phenol. Okay, so C is 1, 2, 3, 4. CH2OH. That's what it would have come from.